Hey everyone, in this session, let's understand a very important concept for each and every machine learning engineers and data scientists, which is nothing but outliers. Understanding on outliers is an essential skill for a machine learning engineer. What is outlier? Data points that deviate significantly from the other observations in a dataset known as outliers. As you can see here in this picture, most of the data points are here, whereas there are few outliers because these data points are deviating significantly from other observations. There are a number of different types of outliers: global outlier, contextual outlier, and collective outlier. Global outliers are also known as point outliers, where we only focus a specific data point which is deviating significantly from the other data points. In case of contextual outlier, which is also known as conditional outlier, where based on some condition we get specific data points which are far from the other observations, whereas collective outliers are a group of data points which are deviating from the other observations we have. So in case of global outlier, we specifically focus on a specific data point. For contextual outlier, we consider the condition. For collective outliers, we get a group of data points which are deviating from the other data points. Let's understand why we need to understand about outliers and why we need to handle them effectively. If we have outliers in our dataset, it might affect our analysis. It can distort our statistical analysis. It can mislead the model interpretation. Furthermore, it compromises the model performance. That is the reason it is very important for us to handle the outliers first before starting any analysis or model training. As a part of data preprocessing step, we have to handle the outliers effectively. Now the question is how to detect outliers. It can be done using visual inspection. For example, using scatterplot and boxplot, we can easily identify if there are some outliers in our dataset. However, using visual inspection, we will not be able to pinpoint the entries in our dataset which are outliers. For that, we have to rely on statistical method. There are a number of statistical methods through which we can identify the data points which are outliers in our dataset. Z-score and IQR are two very important and popular techniques to identify outliers in our dataset. In our next slide, we will understand Z-score and IQR in detail. Now, once we have detected outliers in our dataset, what should we do? Should we remove them off from our dataset? No, that would be a very big mistake if we remove them from our dataset without analyzing it. Domain knowledge is essential for handling outliers. Let's understand how can we calculate Z-score and IQR or Inter Quartile Range. These are two statistical methods through which we can identify the entries in our dataset which are outliers. Z-score measures how many standard deviations a data point is from the mean of a dataset. Z can be calculated as x minus mu by sigma, where x is the value of the data point. Remember, x is the individual data points we have in our dataset. Mu represents the mean of the dataset and sigma represents the standard deviation of the dataset. So using this formula, we can evaluate Z-score for each and every entries in our dataset. Finally, the data points with Z-score above a threshold can be considered as outliers. Usually we put upper bound of Z value is 2 and lower bound of Z value is minus 2. However, it is very subjective for your problem statement. Based on the domain knowledge, you will consider the upper limit and lower limit of Z-score. Hope you have realized how can we evaluate Z-score. During our coding session, In Jupyter Notebook, we will see how can we write Python code to evaluate z-score. Let's concentrate on Inter Quartile Range or IQR value. IQR is calculated as difference between third quartile and first quartile of the dataset. Third quartile means 75th percentile. First quartile means 25th percentile. Once we get first quartile value and third quartile value from our data set, we can calculate IQR, which is nothing but the difference between third quartile and first quartile. You can see it in this picture. Once we have evaluated IQR value, we can easily calculate lower bound and upper bound. Lower bound can be calculated as first quartile minus 1.5 into IQR, whereas upper bound can be calculated as third quartile plus 1.5 into IQR. After calculating lower bound and upper bound, we identify the data points which are below lower bound or above upper bound. Those data points will be considered as outliers, what you can see in this picture. Now let's jump into Jupyter Notebook. We will write some code to evaluate z-score, IQR. Along with that, we will see how outliers are affecting our model accuracy adversely. We are in our Jupyter Notebook now. Initially, I have imported few of the important libraries we will be using for our example. Pandas used for data preparation. We will be using a simple linear regression model to show you how outlier is affecting our model. We know train test split method will be used to split the entire data set into training data and test data. We have also imported matplotlib so that we can visualize few of the outliers with the help of scatterplot and boxplot. Let's take very simple data set because our aim is to understand the effect of outliers in a machine learning project. Here, if you see, we have work experience versus salary dataset, where the first value is the work experience of a person and second value is the CTC or cost to company. Let's create a data frame out of this data. For simplicity, I have only taken 7 different data points here. We are creating a simple linear regression model. Our aim would be to predict the CTC based on the year of experience. We are splitting the entire data set into training data and test data, where 20% of the data will be reserved for testing the model. We will use the test data to evaluate the accuracy of the model, and training data will be used to train the model. With the help of fit method, we can train our linear regression model. Now let's evaluate the accuracy of our model. As you can see, the accuracy is 85% in our case. For visual inspection, we can use scatterplot and boxplot. Let's plot the scatterplot to understand if there is any outlier. We can get a specific pattern when we are plotting all the data points as a scatterplot. Looking at this data, we can understand that there is no specific outliers present in this data, because as the years of experience is increasing, salary or CTC is also increasing, and there is no exceptional data point what we can see from this scatter plot. We will revisit this scatter plot after introducing an outlier in our dataset. We will see how it is differing from this pattern. Let's plot the box plot with the help of CTC column. Even here, you cannot see any points in your upper bound as well as after your lower bound, which indicates that there is no outlier as such. As there is no outliers, our model is performing decently. 85% of the time, our model will predict the CTC of a person accurately. Now it's time to introduce an outlier. Let's say we have added 2 more zeros here. That means the salary of this person is exceptionally high. Let's see if by this we can introduce an outlier or not. If you can see, with an outlier, our model score reduced drastically. Earlier, it was 0.85 or 85% accuracy. Now the accuracy dropped to 0%. By this, you can clearly understand that if you have outliers in your dataset, how it is affecting to the linear regression model we are using in this example. Let's plot a scatter plot here. Now you can easily identify that this data point is clearly an outlier because it is not matching with this pattern. Let's plot boxplot also. Boxplot is a very effective tool to identify the outliers in your dataset. If you see here, you can see there is an outlier in your dataset which is above the upper bound of your dataset. Hence, with the help of scatterplot and boxplot, you can easily identify if you have outliers in your dataset or not. However, with the help of visual inspection, you will not be able to identify the entry which is an outlier in your dataset. For that, we have to rely on the statistical methods. Z-score is one of them. In order to evaluate Z-score, we need mean and standard deviation. That we know from our theory class. During our theory class, we have seen what is the mathematical equation for Z-score. Hence, we are evaluating mean value and standard deviation value of our CTC column. And then for each data points, we are evaluating x minus mean by standard deviation, which is nothing but the formula of Z-score. And finally, we are adding Z-scores in our data frame. Let's print it to check out the Z-scores of each and every entries. If you see here, all the values except this has Z-score between 2 to -2. If we assume 2 as our upper bound and -2 as our lower bound, then this entry is an outlier because the Z-score of this entry is above 2. However, as we have discussed earlier also, this upper bound and lower bound can be evaluated based on the domain knowledge or based on the problem statement you are trying to solve. Let's move to IQR value. With the help of numpy.percentile method, we can easily evaluate the Q1 or first quartile value and Q3 or third quartile value very easily. Here, with the help of percentile method, we are evaluating first quartile value and third quartile value of our CTC column. Once we have first quartile and third quartile, we know the formula of IQR is something like this. Difference between third quartile and first quartile. After evaluation of IQR value, we can easily calculate the lower bound and upper bound. Lower bound can be calculated as Q1 minus 1.5 into IQR and upper bound can be calculated as Q3 plus 1.5 into IQR. Let's run this to check out the lower bound and upper bound in IQR method. Here we are evaluating the lower bound and upper bound of CTC value. Any data point above this upper bound or lesser than the lower bound will be treated as outliers. In this case, this entry is an outlier because the CTC value is above upper bound. Hope you have realized how Z-score and IQR statistical method is helping us to identify the outliers from our dataset. Now, the question is, what should we do with these outliers? Should we remove them off? The answer is, it totally depends on the business case. You should have adequate domain knowledge to take a decision whether we should remove the outliers or we should keep or even we should modify the outlier values. Let's understand the takeaways from this session. In this session, we have discussed about a very important concept called outliers. Outliers are the data points which deviate significantly from the other observations in our dataset. Now we know different types of outliers, why we need to understand outliers and handle them effectively. During our coding session, we have seen how a single outlier in our dataset is affecting the model performance adversely. Now we know how can we detect outliers from our dataset. Two different ways are there: visual inspection and statistical method. Using visual inspection with the help of scatterplot and boxplot, we can easily identify if we have outliers in our dataset or not. However, identifying or pinpointing to a specific entry in our dataset as outlier is difficult with the help of visual inspection, and that's the reason why we rely on statistical methods. Z-score and IQers are two very famous statistical methods to identify outlier entries in our dataset. Remember, once we have identified the entries in our dataset as outliers, we will not be removing them because we need domain knowledge to handle the outliers. We will discuss with our business team, we will think about our problem statement, and then we will take the decision of handling outliers. In this slide, we realized how we can calculate Z-score and IQR value. We have even written the equivalent Python code for Z-score as well as Inter Quartile Range or IQR. Hope you have enjoyed this session. Thanks a lot for watching this video.